5 dose. We're in this to win this, and we're here. So let's make it clear. The ready is what I like to call just plug and chug. That's it. You're determining if given values are solutions to a two-variable equation. This is giving you some equation. These are some points that you're being asked to plug in to see if they are going to make a true statement or not. That's up to us to figure out if that's going to happen or not. We'll take a look at one of these and then jump to probably problem 4. Hope you're having a great day. Let's do this. So I'm going to look at A. A is asking us if 2, 4 is a solution, again, to the equation 3x plus 2y equals 12. We are going to just plug in. We have this point. We have our x coordinate. We have our y coordinate. Instead of 3x, I'm now going to put in what? What do you think? You should be putting in this 2 in place of x, this 4 in place of y, and this should all equal 12, but let's try it. 3 times 2 is 6, 2 times 4 is 8. This should all equal 12, but is this left side really going to be equal to 12? Think about this. Hopefully you're saying no. 6 and 8 is going to get you 14. That does not equal 12. So collectively, we would say something to the effect of 2, 4 is not a solution for the line, or rather the equation 3x plus 2y equals 12. We could say something like that. So we would say it's not a solution. Big deal there. Take a moment, pause the video, try D. Pause the video, try D. Shout out to those students that paused the video. Hopefully your work looks something like this. You were plugging in where x is 0 and y is 6. You would eventually see that you get a true statement, 12 equals 12. Again, simplifying the right side, 3 times the 0 gets you 0, 2 times 6 gets you 12. You're adding that 12 on. Positive 12 equals positive 12. And then you would want to say something like this. 0, 6 is a solution for the equation 3x plus 2y equals 12. Hope that sounds good. Hope you got it right. I'm not sure if the video recorded all of this, but if you were solving for A, you're given 2 as x, you're trying to solve for y. Eventually, you would put in 2 in place of where x was. 2 plus y equals 6. Get rid of the 2 on both sides. Y equals 4. Lo and behold, your answer you need to write in here is 4. Hope that helps. Remember all that graphing review that we did in 5.1? It's coming back again. Here we are. We're now graphing a linear inequality, and we are going to be making a note of algebraically and graphically points that are correct. So one that is a solution, one that's not a solution. We'll start with 7. When I look at 7, I'm pretty much going to go about graphing this similar to if this was just y equals 3x plus 4. Don't let that inequality fool you too much. And based off of that, if you wanted to use a sentence to describe this equation, you could say, starting at 4, we add 3 x times. You could also say something along the y-intercept. What's the y-intercept going to be here? Hopefully you're saying 4. Hopefully you're saying that our slope is, well, what's our slope? Maybe try this as a fraction. What's our slope as a fraction? Hopefully you're saying 3 over 1, where our rise is 3, and our run is 1. Kind of a boring function, but that's okay. We know that we're starting at 4, so let's start at 4. We talked in 5.2 about what type of line we wanted, if we wanted dashed or solid. So we see that this is an equal to, so what do you think? Are we going to use a dashed or solid line when we graph this? Hopefully you're saying solid. So there's no dash. And then maybe another question to ask is, where are we going to shade? if y is less than all of this. Hopefully you're saying that we're going to shade below the line. These are two characteristics that I think are important. I know I kind of set up here, the y-intercept's important, the slope's important, but these are also two very important characteristics. Okay, sound good? Maybe take this time now, try graphing this, and we'll touch base in a second. Your line should look something like this. Again, you're starting at 4. You're going over 1, up 3. Your line looks like this. We shaded below the line. It's a solid line. So I showed all of that. Now we're going to be looking at a point that is a solution and also a point that's not a solution. So I'm going to pick a point in lighter blue that is a solution. So I know the point 0, 0 is in the blue. So I'm going to say that 0, 0 is a solution. And we can show this algebraically. We could plug in where y is 0 and also where x is 0. What do you think about this? Eventually, if we simplify it, 0 plus 4 is just 4. Is this a true statement? True blue. So 0, 0 is definitely a solution. Try to find a point that's not a solution. Try that real quick. Find a point that's not a solution. One point you could have used as not a solution was this -3, 4. We see it's not in the shaded area. We can also show this algebraically. If we put in 4 as y, we put in -3 as x, continue to write out the rest of the equation. This is going to claim -9 plus 4 is greater than or equal to 4. But you soon see that you have 4 on the left, and you're claiming here that -5 is greater. What do you think about this? Is this true or false? Hopefully you're saying falso. So lo and behold, we showed that if it's not a solution to the inequality, when we plug it in, it creates a false statement. Whereas if it plugs in and it's true, it is a solution. There you go. The rest of this activity has you graphing and answering a lot of questions that we rewrote. I should note that for 12, you're working with an equation that is in standard form. So be careful here when you're going to solve for y. We've seen problems like this in module 4. So remember, you're isolating your y term. You keep hustling to try and isolate it. So maybe try that out real quick. Maybe think, how could you isolate your y term here? Pause the video, try that out. Just A. So just try and solve for y. At this point in time, you should have tried this problem solving for y. Let's chat about it. You should have deducted 4x from both sides. This leaves you with -2y is greater than or equal to 6 minus 4x. Or if you want to rewrite all of this, you could say -2y greater than or equal to -4x plus 6. Personally, I would leave the -4x towards the front so it looks like a slope-intercept inequality. We can then get rid of this -2, dividing everything by -2. And there's something we have to do here. I don't remember what. Maybe you can recall. Is there something we have to do with our sign in the middle? We got to flip it on them. So flip that direction. It's opening originally towards the left. Now it's opening towards the right. -4 divided by -2 is just 2x. +6 divided by -2 is going to deduct 3. This is now the inequality that you should have written in this setup here. So when it says solve for y, we should be saying we got y is less than or equal to, well, we wrote this out. You should already have it, honestly. What was this? 2x. And what else? -3. Sound good? You should be able to knock out the rest of the work here. If you have any questions, holler, let me know. Thanks for watching.